we consider there is a mass m with the velocity 0 which has been released at a distance 5r, where r is the radius of Earth. At a distance 5r from the center of Earth, it has been released. So obviously it will start accelerating towards Earth and it will strike Earth with some velocity. We are asked with what velocity this is going to strike the Earth's surface. So what we say is we take two positions. One is this and the other is when it is going to strike the surface of Earth. Because there are no dissipative forces, because there is no external force, so it means the total mechanical energy of this system is conserved. If we take position number 1, let's say when it is over here, we say P1 plus KE1, we find that. And when it reaches over here, once again, we find P2 plus KE2. Then what we do is, that is a total mechanical energy. This is what? This is total mechanical energy in configuration number 1. And this is total mechanical energy in configuration number 2. So this should be equal to this. So now what we do is we directly just put the values. Potential energy 1 in this configuration is minus GMM upon what is the distance between 2 is 5r. Plus kinetic energy is obviously equal to 0. This is stationary. When it comes over here, let's say in configuration 2 it has a velocity v. So now potential 2, when it reaches over here, the distance between this body of mass m and Earth center is r only. So potential energy, we know gravitational potential energy is minus gm upon r plus kinetic energy of that. This is going to be equal to half m into v square. So this is total mechanical energy. Though if we take this as isolated system, when it goes over here, then certainly the Earth will also be moving, so that the center of mass of this system doesn't move. But because this is so massive, we are taking its velocity or displacement almost equal to 0, that only this is moving. So it comes out to be minus gm upon r plus half mv square. So this is the total mechanical energy when it has reached over here. So now what we do is we say total mechanical energy for configuration 1 is equal to total mechanical energy for configuration 2. We are applying the conservation of mechanical energy principle. So it comes out to be minus GMM upon 5r is equal to now minus GMM upon r plus half mv square. M and m, they get cancelled. We can also make an important substitution which we have been using number of times. That is on the surface of Earth, if this is mass m, if mass of Earth is capital M, radius is r, and small body of mass m is over here, we say GMM upon r square, that is force of attraction, is the weight only. So from here we have been using GM is equal to GR square, an important substitution. We can put it over here, and from here we can get the value of with what velocity this is going to strike the Earth.